Hello all and welcome to my YouTube channel. Today we are going to see an interesting topic. We'll be deploying an agentic AI application. So you might have already seen this particular application that we have built in the previous video, the AI Warranty Fraud Detector, which is a multi-agent solution that we have built with the help of LangGraph and which is responsible in order to detect whether the claim submitted by the customer, we can approve it, reject it, or we can escalate it for the human approval. So we have already seen the development activity of this particular project. All the details, the line by line code we have already covered in the previous video. So if you have missed that, please go ahead and check out that. The link is there in the description below. Let me give you the quick glimpse of that particular video. So this is the video which is available on our channel iTech. Please go ahead and check out that. Please subscribe to my YouTube channel. And as you can see, this is how user can upload the claim. And for that particular claim, you can see the different information that is available, like when the claim was submitted, what is the claim date, what is the average mileage. So this claim information is from the automobile industry. So you can see this is the for this particular four-wheeler, the customer have submitted the claim against the accident, and you can see all those details available. And the part that customer wants to replace is the headlight. And then you can see we have our AI agentic application. It has detected that, okay, we need to reject this, and we have given all those details like, okay, headlight replacement is not covered in this particular policy. All those details we have covered. And you can see we have covered the architecture diagram as well. Then we have built the end-to-end project line by line code we have covered. So if you have missed that, please go ahead and check out that. Now let's straight jump on to the today's agenda. So today we'll be seeing how exactly we can deploy this particular application, and we'll be using an Azure Web App services in order to deploy this. So whenever we are thinking about the deployment, the one tool that comes into the picture is the Docker. So let's understand what exactly is the Docker and how exactly it is going to help us deploy this particular application. So for deploying the application, we need to containerize our code, and we'll be using Docker in order to containerize that. First of all, what exactly is the Docker? So let's understand that. Okay. So Docker is nothing but, let's say we have an application code, whatever code files that we have written, we need to create a Docker file out of that particular code, and that Docker file, and from that Docker file, we need to create the image and we need to containerize that particular image. Now, what exactly is the Docker file? So Docker file is nothing but the file in which we are going to write the command that we need to execute in order to run the application. It is a simple file. We'll be seeing how exactly we can create that file. Then it comes the image. Now image is nothing but the blueprint of your application, how exactly you are going to run your application. All those details are available in the image. So we'll be seeing how exactly we can build this particular Docker image. And once the Docker image is available, in order to run the image, we need a container. And that's where we use Docker container so that we can run that actual application. So in simple terms, if you want to understand, Docker file is just the sequence of steps that we have written. Just a simple normal file, just like our Python file. Image is nothing but the actual replica where we have given all those details, how exactly the step by steps we need to execute, how exactly we are going to run the application. So basically it's a recipe. Let's say if you want to bake a cake, then image is nothing but the recipe to bake a cake, and container is nothing but your actual cake which is ready once it is baked. So that's the container. Now, why do we need to containerize the application? Because whenever we are running any application in local, it runs very smooth. But whenever you want to deploy that application into the production environment, then what happens is that it fails to execute the same commands that are running in your local. And in order to fix these particular differences or issues, we have this particular Docker. So Docker help us combine all those details, all the package files, the application code files required to run the application into one container. And then we can ship this container to any environment where we need to run the same application. So in this case, the container will collect all the metadata that is required. And once it is containerized, you can ship that container to any environment, and same code which is running in your local will run into your production environment or any environment for where you want to run the application. So that's the purpose of Docker. Now let's go ahead and start building the Docker file. So first of all, let me give you the glimpse of code that we have built previously. Okay, so this is the code that we have written in the previous video. And as you can see, we have used LangGraph in order to build this agentic AI application, and we have used Azure OpenAI. So if you have missed that, please check out those details. I'll not go ahead and cover the complete code that we have written, but just to give you the glimpse, you can see these are the different agents that we have built, and then you can see, and then we have built the workflow with the help of LangGraph. Now, so the code link is available in the description below. So you can see this is the code that is available on my GitHub channel. So same code, I have cloned it, and now on this particular code, we'll go ahead and start writing the Docker file. So first of all, let's create the Docker file. So Docker file. Okay, you can see the Docker symbol once we create the Docker file. So this is the Docker file. Let's go ahead and start writing the Docker file quickly. So whenever we want to run any application, first what we need is the environment, Python environment, because whole code we have written in Python. And whenever we want to execute this particular code, we need a Python execution environment. So that environment is already available as a Docker image. We just need to use the existing Docker image provided by Python. So there are different environments that are available for Python, different based on the different versions of Python, and we'll be utilizing a lighter version of image that is available. So that is nothing but our Python 3.11 Slim. So the first command that we'll be writing is, so basically it is going to use this particular image that is already available, Python 3.11 Slim. It is just like you have selected Python, right? And this particular Python, you will going to execute your code. So that's what we have written. Now the next step is we need to go ahead and define the work directory. So as you can see, it has already suggested that. So let's go ahead and define that. Now work directory is nothing but in this particular image, it will create one app as a folder, and in that app folder, we will go ahead and add all our code. Now the next step is that we need to copy the code. So in order to copy that, okay, you can see copy project files. So let's go ahead and hit enter. So the next step is copy dot slash app. What exactly this means is that we are going to copy all the files that are available at the current working directory, dot meaning this particular working directory, and it will copy those files from this directory to particular application folder that we have created. Okay, very simple, because we want to execute the code, right? So we want that code available in that particular file. Done. Now is next step is to upgrade and install the dependencies. Now in order to install the dependencies, we can use run command, and you can see this is the simple command that we'll be using. Pip install -- upgrade pip, and then basically this is in order to upgrade the pip, because we are not sure the Python image that we'll be using, base image, what is the pip version that is available. So always upgrade the pip, and then and we'll be using shell command in order to install these requirements. Now the simple command to install the requirements is pip install -r requirements.txt. That's the simple thing. Now, why it is giving the code recommendation for me? Because I have already written that particular code while testing this particular application. That's where it is recommending that. But again, the Docker file creation is very simple. Now, once this step is done, then we need to expose the Streamlit default port. Now, we are going to expose the application to this particular port 8501. You can define any port. So we are selecting 8501 as a custom port. So whenever we will run this application, it will run on this particular port 8501. So that's the next step of defining the port. Now the last step is to run the command application. Now whenever we want to run the application, we use the command streamlit run app.py. That's the simple command that we run. And if you missed that, we are in the previous video also we have used the similar command streamlit run app.py. Now same things we need to define in the form of command. So you can see this is the format that is used by the Docker file cmd, and we need to define each individual command in the quotes. So streamlit run app.py. On top of that, we need to define the port on which we are going to run the application. So that's what we have given -- server.port 8501. That's the thing that we have given. And the next thing that we need to add is the server address. So let's go ahead and add the server address. Now server address will be particular localhost address. So that is the command that we have given, and in that command we have given the port on which we want to run the application and the localhost address. Done. Our Docker file is ready. It is that simple to create the Docker file. But let's quickly do a review. We have used the Python base image 3.11 Slim. Slim is nothing but the lighter version of the image that is available, because we don't want to use the complete Python 3.11 in order to run that. That's where we have picked the Slim, which will pick the limited resources that are required in order to run the application. Then we have created working directory app. We have copied our all project files into the app folder. Then we have added a command to install the dependencies. And then we have defined the port on which we want to run the application. And we have given the command that we want to run in order to start the application, streamlit run app.py with the server port and the localhost address. So this is actually not the localhost address. So actually 0.0 is nothing but the application can be accessible from all the environment. So currently we'll be using localhost. So if you are exposing the application, if you are running the application on localhost, it will still work. If you are running the application on the deployment environment, it will still work. So it's just the base address that we have given. Okay, now our Docker file is ready. Okay, so the next step is to install the Docker. So to install the Docker, you can go ahead and search Docker installation, and based on your OS system, you can select. So let's say I'm using Windows. So let's say we can go into that and we can select Docker desktop for Windows, and it will download that and you can go ahead and install that. Now, if you are a Mac user, go ahead and install the Docker on Mac. Again, the steps are very simple. You just need to open the application. You need to select next, 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 and the installation will be done. And if you are facing any issues related to the environment path, you just need to go ahead and add that environment path into your environment variable. That's the very simple step. Now, once the Docker is available, you can go ahead and open the Docker. So let me open my Docker desktop. Okay, this is the Docker desktop I have. So let me delete the old images that I have created. Okay, you can see you have options available here, container and then images. You can see all those details available here. So this is the simple Docker. You will be able to see this particular window once you install the Docker. Now, let's see whether the Docker is installed. Let's hit Docker. Okay, for me, you can see it is returning all those commands. So Docker is installed successfully in my system. So for you, if you are facing any issues related to the Docker installation, do let me know in the comment section and I'll help you with that. Now, once the Docker installation is done, the next step is to build the Docker image and then -t. Now, -t is nothing but the tag that we can give for this particular image. So that image will be recognized with the help of this particular tag. So we can give the tag name as, let's say, Warranty Fraud Detector. This is the tag that we have given. And then we just need to give dot. Now this dot is nothing but whatever is available in this particular working directory. Go ahead and generate the Docker image out of this. So let's hit enter and it will go ahead and start building the Docker image. Okay, you can see it is building the Docker image. So first it will download this particular image. For that image, it will create app.py. Then it will copy these files and it will start the requirements. You can see it is installing the requirements one by one. So let's wait for the Docker image creation. Okay, you can see the Docker image has been created and you can see the steps that it has followed. So first of all, it has used this particular base Docker image. You can see Python 3.11 Slim. Then it has created this work directory. It has copied all the files. Then it has upgraded the pip and installed the requirements.txt and then it has exported the image. So let's check whether the image is created. So let's use Docker image, Docker images. Okay, you can see warranty fraud detector is the Docker that is available. Then we have image ID and the size of the image. You can see it is generated a minute ago. Okay, let's see whether the image is available on the Docker desktop. So this is the Docker desktop. You can see we haven't built the container yet, but if you go into the images, you can see this is the image that we have built around 2 minutes ago, and currently it is not running. So in this particular image, you can see all the details, how exactly the image has been built. You can see from starting, we started with these details, then we have copied the file, we have exposed it to this, and then this is the running command that we have created. So that's the Docker image that it has created. Now you can run the image by clicking on this, or you can go ahead and run the image from the command line. So in order to run that, we can use next command as docker run is the command. Docker build in order to build the image, docker run in order to run the container. After that, we need to give the port. So port, we can define it with the help of -p. And the port that we have used is the 8501:8501. So let's understand what exactly is the 8501:8501. Now 8501 is the port on which the application will run on our local host. So this is the port that our local computer will use, and 8501 is the port that will be used by the container. So whenever user will open the application, the container will use the port 8501 and same port will be used by our local host. Okay, so that's the thing. Now, after this, we need to give the image name, the image we want to run. So our image name is nothing but warranty fraud detector. That's the image. And then we just pass a tag latest. so that whatever is the latest image available, it will go ahead and run that. So you can create a multiple images. Let's say if you are running the build command multiple times, it will create a new image every time, and then in that case it will go ahead and pick up the latest image. So let's go ahead and execute this. Okay, there is a spelling mistake. Let me correct that quickly. Okay, you can see it is collecting the statistics and it has started the application, Streamlit application on this particular local host. Now let's see whether it has started the application or not. Okay, you can see the container. This is the container that it has created. And on the container, you can see the same logs available. So you can open these particular logs and you will be able to see the application. So let's go ahead and open this particular link. And let's open that. Okay, you can see the application is running. If your application is running on 0.0.0, then make sure that you run this particular command localhost :8501 and your application will run smoothly. Okay, you can see the application is running. Here I can go ahead and browse the file. I can upload the claim submitted by the customer. So this is the claim information, the model, the purchase vehicle purchase rate, the claim date, the date since the vehicle is purchased, mileage, what is the damage part, what is the total cost in USD, all those details, and I can go ahead and generate the results. So currently this application is running on Docker, though it is running on local, but as the application is running in local, now the Docker will make sure that the application will run on our production environment. Wherever we are going to deploy the application, it will make sure that it will go ahead and run that. We will not face any issues as such. Okay, you can see it is saying that it is saying that the claim has been rejected, and then it has given the reasoning as well why the claim is rejected, because headlight is not covered under the policy, and all those details. You can see how the conversation have happened across these different agents already we have captured. Those details were already covered in the previous video, so let's not go into that. Now, as the application is running and our Docker is also running successfully, now we can go ahead and deploy the application. Now, in order to deploy that, as I mentioned earlier, we'll be using Azure Web App deployment. So let's understand what exactly it is. Okay, so I have logged into my Azure portal. So you can go to portal.azure.com, and you can see this is the service that we will be using, app service. So you can search here web app, and you can see the app service. You can select that particular, and from here we are going to create this. But first of all, let's understand what exactly is the app service. So let's search web app, and okay, as you can see, Azure App Service is a platform that let you run web application, mobile backends, and RESTful APIs without worrying about managing the underlying infrastructure. Meaning, it is a fully managed service by Azure, which helps you quickly deploy your application. Now, you can see app service supports a variety of web stacks like .NET, Java, Node.js, Python. With the help of these different language, you can build your application and you can just deploy it as a custom container. Meaning once you have your container ready, you can go ahead and quickly deploy your application with the help of web app service. Now, so first of all, let's understand why web app service and how it is different from the Azure Kubernetes service. So let's understand this with the help of the simple differentiation. So now, Azure Web App is a platform as a service, meaning it is a platform service provided by the Azure. It is managed service where all the details, everything, the infrastructure, the backend, everything is managed by the Azure. We just need to make sure that we have a container ready. We can deploy that container on the web app service. So it's the simplest service. Then we have AKS, Azure Kubernetes Service, which is a containerized service where we need to deploy the application as a container. So both supports container deployment. Now, as I have already covered, it is a fully managed by Azure, and the AKS is the custom service where you need to define your configurations. You need to define all the custom configuration that is required as per your project. Now, the deployment process is very simple in Azure Web App. We just need to push the code as a single container. And then in the AKS, we need to develop our YAML file where we need to define all the steps that are required in order to deploy the application. Then from the scalability perspective, it is a simultaneous and auto scale option available on Azure Web App Service. In the AKS, the microservice that we are deploying, we need to select a number of pods that are required in order to run the service, and definitely you can auto scale those pods as well. Then the use case, whenever it is very simple or you have simple APIs that you want to deploy quickly, then you can use Azure Web App. Let's say if you want to build your custom infrastructure that you want to deploy, then you can go with the AKS. Then the complexity wise, the web app is very simple. the AKS is a bit complicated. And then web app is fast and low maintenance deployments because everything is managed by Azure, but the AKS is fully controlled and manageable service. We have more control on this particular service. So both are having its advantages as well as disadvantages. Currently, as this is our first deployment video, we are going to deploy this application with the help of web app service, and later on we'll cover how exactly we can deploy the application with the help of AKS as well. Okay, so the focus for today's video is mostly on the deployment part, and that's where I'm skipping the theoretical parts for this particular video. And if you have any doubts, right, just let me know in the comment section. I'll go ahead and explain these topics in depth. I'll probably create a different videos in order to understand which deployment to select for the in the organization. But in the organization, both the frameworks are used widely in order to deploy the application. So let's quickly jump and see how we can create the service. So, okay, we have searched the web app. Let's go ahead and create that. So we can select the first web app option. Then we need to create a resource group. I have already created one resource group. If you have not created, you can just create new resource group. So I have already created the resource group in order to basically deploy the OpenAI service. So you can see this is the resource group that I have created. Then web app name we need to give. So let's give web app name as Warranty Fraud Detector. So I already tried that. That's where it is available. So Warranty Fraud Detector is the name that we have given. Publish, we need to publish it as a container, right? So let's select container. And operating system, you can keep Linux. So basically the code will run on Linux, which is the most widely used operating system in the deployment environment. So let's select that. Region, let's select East US, or let's go ahead and select anything from Asia. Okay, I'm selecting East Asia. The reason I'm selecting East Asia because we'll be using these particular pricing plans, right? So when I checked the last time, the free plan was not available in East US. So let's select the different region. So based on the availability, you can select the region. Then plan, right? Let's go ahead and select the plan. So we'll be using free plan, but if you want to see but if you want to explore the other pricing, let's click on that. And then out of these two, you can select the proper plan. Now, initially I tried with free plan and it worked, but later on when we are changing the configurations, right, then free plan doesn't work because there are limitations of memory as well. That's where I'm selecting base plan, but yeah, free plan should also work for you. Then let's select this particular plan. So it will provide us the 1.75 GB of memory and one CPU. So that is more than enough for us to run the application. Then next, click on next, and okay, Linux plan, as you can see, once you select the service, then it will auto select the Linux plan. So that's fine. Let's click on next. Now database, you can skip that. The next one is the main thing, that is container. So here we'll be using Azure Container Registry. So we'll be selecting ACR. Now what exactly is the ACR? So the Docker that we are running in local, right? How exactly you are going to store that particular Docker image? So in order to store the Docker image, currently it is stored in local. So particular image that we have created, it is in local. Now, whenever you want to use this particular image, so how exactly the Azure Web App knows that from where to pick this particular image? And on top of that image, it will go ahead and run the container. So ACR is a service which help us host this particular image. Okay, so if you search Azure Container Registry, you can see a registry of Docker and open container images with support of all OCA artifacts. So with the help of which we can build, store, secure, scan and replicate and manage the container images and artifacts with the help of fully managed service. So that's the ACR. So we'll need this ACR in order to store this particular service. But currently we don't have any ACR available. So first of all, we need to go ahead and deploy the ACR service. So let's go to the home page again. And on the home page, you can select the Azure Container. You can search the Azure Container Registry. And this is the one that we'll be using, Container Registries. Let's click on Create. Select the subscription. So I have already created this Azure subscription, so we'll select that. Then resource group, let's select the one that we have created, RG OpenAI. Then registry name, let's enter the registry name as Warranty Fraud Detector. Then location, let's keep it East US, that's fine. Domain name, label scope, you can keep it as unsecure. Now this is the registry domain name that it has created, warranty fraud detector.azure.io. Let's select this pricing plan. So let's click on basics because I think basics is more than enough for us. Then role assignment, let's select RBAC registry permission and hit next. You can keep all those details and click on create. So this will go ahead and create a Azure container registry for us where we can push our image, and from there the Azure Web App will read the code and it will execute those commands, and the Web App will provide a compute power in order to run that particular Python file. So that will be able to serve the application. So okay, you can see the deployment is in progress. Okay, the deployment is complete. Let's go to source. Okay, you can see this is the container registry that it has created, and you can see the options that are available in order to deploy the image. So we'll be selecting, let's say, push an image option. So we'll be pushing the image manually because we have not built the continuous integration and continuous deployment pipeline. So currently, just to keep it simple, we'll be manually going ahead and pushing this particular image from our command line terminal. And later on, right, in the upcoming videos, I would like to cover those parts. So if you are interested, just let me know in the comment section. I'll cover the entire CI/CD part, how exactly we can build the CI/CD in order to automatically integrate and deploy the particular agentic AI applications. So if you click on push an image, you can see these are the commands that we will be using in order to log into the Azure portal. And then now this is the test command that they have given in order to push the simple code for hello world, but we'll not be using that. And now currently you can see under the repositories, you will not find any repository available. Once we push the image, you will see that repository available here. So let's click on overview, push an image, and let's use these commands AZ login and AZ ACR login. So first of all, in order to make sure that AZ login is working in your terminal, you will have to make sure that the Azure command line interface is installed in your system. So just search Azure CLI and you can see the options that are available based on your operating system. Go ahead and install the Azure CLI. Let's say if you are using Windows, so you can go ahead and install the Microsoft installer MSI. Okay, let's say we are selecting Microsoft installer MSI, and then if you scroll below, you'll be able to download the Azure CLI based on your operating system. So let's say if you are downloading this, it will download the file. You just need to double click on that and install by clicking next, next, next. And in case if the AZ CLI is still not working, you will have to configure the path into your environment variables. So that's the simple step that is available. So let me pause this because I already installed that. Now let's open the terminal, and here now we need to log into our Azure portal. So in order to log in that, the simple command is AZ login. So let's select this, and this will ask you to authenticate your application first time, and then you will have to select your resource. So you can see this is the pop-up that came, and I'm going to select my account, continue. So as I have enabled the multi-factor authentication, so I have already logged in previously, that's where it is not asking me to authenticate. But if you are doing it first time, it may ask you to authenticate. It may ask you to enter the password, or it may ask you to approve from your mobile authenticator app. So this is the subscription that is available in my Azure account. Sometimes the AZ login doesn't work. You may need to pass the tenant ID into that, and the command for that is AZ login -- tenant ID. Let's say this is my tenant ID, so it will show you some error that okay, not able to log into this particular subscription. Please use the command Azure login -- tenant and then the tenant ID that you need to enter. So you can use that particular command. For me, it is working now because I have already logged in previously. Okay, so let's continue. It is saying to select the tenant. So this is the one that is available under my subscription. So I'm just going to hit enter and it will select that. Okay, so I'm able to log into my application. Now the next command is AZ login to the Azure Container Registry. So AZ login, I think that command was AZ ACR login. AZ ACR login, okay. Let's copy this command itself. So that's the container registry name that we have given. So let's add that AZ ACR login -- name and the name of the container registry. Okay, let's hit enter and see. It will log into our container registry so that we can push the image that we have created locally to the container registry. Okay, you can see login succeed, meaning we are able to log into the Azure Container Registry. Now the next step is to push the image that we have created locally to the container registry. And the step for that is very simple again. So first of all, we'll have to create a Docker tag so that the Docker knows where exactly it needs to push the image. So for pushing the image, the command is very simple, Docker push. And then we need to give the name of container registry. But before that, we need to embed the path where exactly we want to push that. So for that, the command is Docker tag. What's the name of our image? Yeah. So the command is Docker tag warranty fraud detector is the name of image. And then we need to give the path. So this is the part that we'll be using because we need to push to this particular path. Warranty fraud detector.azure container registry.io, and then we can give the name of the image and the latest. Out of this, we need to pick the latest one. So now it has just created a tag. So if you see in the Docker images, there will be two images available. Okay, you can see this is the first one that we created, and the second one is where we need to push this particular image now. So you can see it is the Azure CR at this particular location, warranty fraud detector.azurecr.io will be pushing this particular warranty fraud detector. So let's go ahead and use the Docker push command now. Docker push and this particular image name. Warranty fraud detector.azurecr.io warranty fraud detector. Let's hit enter. We can see it has started pushing the repository to the Azure container registry. So this will take ample amount of time because the image is of size close to 1.27 GB. So it will push that particular image, whatever code that is, or whatever image that we have generated in locally, right? And we have tested that it was working. Now, as we are pushing this particular image to the Azure container registry, it will go work in that particular environment as well. So now it is containerizing the code and pushing it to the Azure container registry. So let's wait for this particular completion. Okay, you can see the image has been pushed successfully. So let's go ahead and check out that on the portal. So here now you can go to the repository section and let's see whether the image is available. Okay, you can see the image is available with the name warranty fraud detector. And for this particular image, you can see this is the SHA-ID that is available. So let's skip that for now. And you can see the tag available is the latest. Now this image, we will be passing it into our Azure Web App. So let's go to the Web App. And here now, if you see, let me just reselect the option and you should see the particular registry. You can see this is the ACR that we have created. Okay, cool. Now that part is done. Now most of the things are done. Next step is the authentication. So for authentication, if you see, there is a manage identity available. So let's select that. Identity, this you can select the default one that is available, or you can create a new ID, that's fine. Then image now. Okay, so what is the image that is available? So the name of image was warranty fraud detector. That's the image name. Tag is latest. We have already seen that. Port is 8541. Let me cross check the port. Sorry, 8501. Startup command, let's not mention because we have already given the startup command in our Docker file. So if you see in the Docker file, we have already given the startup command. So let's skip that. Let's select networking. You can keep these things default. Okay. Let's go ahead and create. Okay. So let's wait for the web app service creation. So you can see all those details. The estimated cost is 16 or 14.60 US dollar per month. Okay. And then this is the total memory that is available and the CPU compute power. So let's wait for the deployment. Okay, the deployment has been completed. So let's go to the resource. Okay, this is the web app service that we have created. Now, okay, so let's check in the deployment center section. So we should see the main container that it has created. And under that main container, we should see the Azure container registry that we have created. Okay, you can see this is the main container. And you can see at ACR, it has picked the warranty fraud detector. If you click on that, you will be able to see the details that are available. We can see warranty fraud detector, and this is the port that we have defined. Okay, cool. Let's close this. Let's click on overview. And that's all. Our deployment is done and we are ready to test the application. So we have made one mistake. I think we have pushed the environment file. So if you see, we have pushed this particular environment file along with the Docker, and that's where what will happen now. It will use the environment files that we have. It will use the secrets that we have added into the environment, but that's not the industry practice. So on the web app, there is another section available, environment variables, where you can load your secrets. But let's test the application first. Okay, so you can see you can click on this browse option in order to load the application, or you can use this particular default domain on which the application is serving. So let's click on that. Okay, so you can see it is loading the application. Yeah. Okay, you can see it has loaded the application. So there are some mismatches. We are not able to see this particular box clearly, but that's fine. So yeah, we have deployed our application successfully with the help of Azure Web App. Let's test the application. So let's click on browse. Let's select the file. Okay, you can see the data that is available, and let's click on generate results. Hope it should work. It should fetch the environment details as well, because we have pushed the environment file along with the code. Yeah, cool. It is working. So you can see it has escalated the submitted claim by the user for a human review. Okay. So, and below you can see the conversation, how exactly the conversation have happened, all those details it has captured. Meaning the application that we have deployed locally earlier is now deployed on the Azure cloud, and anyone can, with this particular link, anyone can be able to access this particular application. So let's test whether we'll be able to access this application. So I'm opening a new incognito mode, and here I'm accessing this particular application. So you can see this application is loading into this particular incognito as well. Because we have not added any authentication, that's where it will work. So if I share this link across anyone, right, they will be able to use this application. So that's how we can quickly deploy the application with the help of web app, and we can share this particular deployed link or deployed URL to our users so that they can go ahead and access the application that we have built. And yeah, so if we go back, so I'm not covering all those details how exactly this is happening, because we have already covered this in the previous video. Now the thing that we have missed is we have pushed the secret file along with this particular code. So let's fix that particular part quickly. So open the Docker ignore file. Okay, so how exactly we can keep this particular file? So let's create a Docker ignore file, create new file, dot Docker ignore. Now, just like git ignore, Docker ignore help us ignore whatever stale code that you have or unnecessary files that you have. You can skip those files uploading to the image. So this is basically a standard practices. We should not push the stale code or the practice or test notebooks that we have built into the production or into the image. So here you can see agent.ipynb is the first file that we created in order to test the agentic AI framework, which is not useful. We are not using that because the main file that we are using is app.py and main.py. README, we no need to push it to the image. Then these screenshots, the data we no need to push. So, and the environment file as well. So let's add those details into the into the Docker ignore. So let me quickly add that information. Okay, so you can see I have added all those information. Some cache file that is not at all required as we are using Python. So or whenever you are creating a virtual environment, it adds these cache environment. Then virtual environment we no need to move because we are going to create new environment on the deployment on the deployment side. So we no need to push those details. env we no need to push. Here let's add .env as well, because we no need to push the .env. Then some cache files, the SQLite or DB files, we don't push those data. From data, I have skipped the CSV files, because if you see currently in the data, auto driver warranty policy is the standard document that the AI application that we have built uses in order to compare the claim submitted by the customer against this particular standard policy document. So we need to push this. And again, it is not standard practice to push any files into your image. Ideally, the standard practice is to store these details into your storage location, maybe a blob storage or any other location. You can store these particular files, and then you can read those files from that storage location. But again, to keep it simple, let's keep that file, but let's definitely remove these two CSVs. That's what we have done. Agent.ipynb, no need to move. README, we no need to add that. Any log files and other details, you can easily get these standard talking note files on the internet, and you can copy those content here. So let's say we have done that. Now, first of all, let's go ahead and delete the image that is available. So these two image, let's go ahead and delete those two image. because we'll be recreating the image. Container, let's go ahead and delete the container. Okay, the image was running, that's where I was not able to delete that. So I have deleted the container first. And now you can see we have clean Docker available. So let's go ahead and recreate the Docker file. So again, the command to recreate is docker build -t warranty fraud detector with dot. So just in order to avoid the cache, I'll just add one command. Again, it's a standard practice. --, no cache. Let's hit enter. Sorry, my bad. The command is docker build --, no cache. And then we can add -t and the name warranty fraud detector and then dot. Okay, cool. Let's build the Docker image. You can see the Docker image building has started. So, okay, you can see it is installing the requirements that we have added. Once the installments are installed, it will create the image and we can push that image to the ACR. So while this is happening, let's go ahead and delete the ACR image that we have created. So go to this particular ACR that we have created and let's select and delete the repository. Okay, we have successfully deleted the repository. Let's refresh it and validate it quickly. Let me refresh the page. Okay, you can see we don't have any repository available. Let's go to code. Okay, it is still going on. Let's wait for the completion. Okay, you can see the image has been created. So let's verify that. Okay, so the image is available. Now we don't need to run the Docker now. We can directly go ahead and push the image. So for pushing, we use this particular command. But before that, we need to add a tag. So you can see this is the tag that we have added, Docker tag warranty fraud detector, the warranty fraud detector.azure.cr.io and the name of the image. So let's use this. Okay, so under Docker images now, we should see two tags. Yeah, now let's go ahead and push the image. So for pushing, we use this particular command, Docker push warranty fraud detector and the path. So let's go ahead and hit. So again, it will go ahead and push the Azure Container Registry. So again, it will take some time. So let's wait for the completion. Okay, you can see the image has been pushed. So let's go ahead and check out that. Let's refresh. Yeah, you can see the image is available. And again, you can see the tag is latest. So we no need to change any other details. So let's go to the web app and under the web app. So if you expand the deployment section, so if you expand the deployment section, you can see the deployment center and you will be able to see the logs. Okay, so there are two types of logs that you can see. First one is the application log and second one is the deployment log. Now in the deployment center, you'll be able to see the deployment logs where you can see how exactly the Azure Web App has pulled the image and whether it is able to run that particular image or not. So you can see creating a container with image, it has created this particular container and fully qualified image, all those details you can monitor in this particular deployment log. So we'll cover this part once we build the complete CI/CD pipeline. So at that time, you'll be able to understand how exactly you can monitor the logs. You can see it has pulled the latest image and all those details it has captured. Now, let's go into the main container and see, okay, this is the image that is available. So we no need to change any other details here. So let's say whenever you are recreating the image and if you are giving another image name, then you can go ahead and update that name here, but we no need to update anything. And second log that I talked about is the application log. Those you can review it. Those you can view under monitor section. So you can go to the log stream. And here you will be able to understand how exactly the logs are available for the application. Okay, so you can see it is printing this part, meaning our Streamlit application is running. These warnings we can ignore, that's fine. Now let's go to the overview. So as we have recreated the Azure Container Registry, let's go ahead and restart the application. So once we restart that, it will pick up the latest image. And now let's click on browse or click on this particular option. Let me click on browse this time. Okay, so you can see it is giving this particular error that, okay, Azure OpenAI is not available. OpenAPI key we have not defined because now we have not pushed the .env file, which is the ideal practice. What we need to do is we need to set the secrets onto our web app environment variable section. So let's quickly do that. Okay, so if you see under the settings, we have this environment variables available. So let's click on that. And currently there can be some default environments available. So you can see this is the default environment that is available. Let's ignore that. So this is just required for the web app. So let's click on add, and we'll be adding the environment secrets. So from the environment file, let's select the first secret that we have, Azure Open API key, and let's select the value as well. Let's add the value, apply. Let's add another one, the endpoint. Let's go ahead and add the endpoint and apply. So we have added both the environment variables. Now let's go ahead and apply and confirm. Now after this, we need to restart the application so that we can see, so that it can load the environment secrets. Okay, so let's go to overview once again. Let's click on restart the app. Okay, so app has been restarted, and let's click on the default domain that is available. And this time it should go ahead and open the application because it should read the environment details from the environment config. And why it is working? Because we have added a code to load the python.env. Yeah, you can see it is loading the application, and we have fixed that particular issue. So yeah, that's how it should work. And we have already tested the application, so we no need to test it again. But yeah, now we have deployed the application with the help of Azure Web App. So yeah, I hope the detailed steps that we have covered in order to create the web app application, in order to deploy the web app application is clear to you. So I'll attach the steps that we have followed into the code, and also I'll push the Docker file that we have created to the GitHub repository, and I'll attach that link into the comment section below. So yeah, I hope this session was helpful for you. And once you are done with all your testing, please make sure go ahead and delete all the resources that you have created. So at the end, what I will do is, this is the RG OpenAI resource group that I have created, under which you can see we have created the OpenAI service from where we are reading the GPT-4 model, the warranty fraud detector, Azure Container Registry where we have pushed the image, and the warranty fraud detector where we are running the application. And this is the service that we have created, the app service plan for this particular web app service. So, and the manage identity that we have created. So we'll go ahead and delete all those details. So I'll click on delete resource group, and I'll delete the resource group so that it will make sure that we have deleted all the services that we created to save our cost. So yeah, I hope this was helpful for you. And if you are interested in more such videos where you want me to cover more end-to-end AI projects, so this was the one where we have covered from basics. We have understand how exactly we can build the agentic AI application with the help of LangGraph, and then we have seen how exactly we can go ahead and deploy the agentic AI application. So if you like this particular video, I would highly recommend go ahead and like the video, subscribe to my YouTube channel, and share it with your friends. So I'm investing a lot of time and energy in order to come up with such good content. So if you, as an appreciation token, I would highly recommend please go ahead and like the video, subscribe to my YouTube channel, and share it with your friends. So, and if you are interested in more such videos, please do let me know in the comment section what next video you would like me to cover. And also if you have any questions, please let me know in the comment section, and I'll be happy to answer them. So please stay tuned for the upcoming interesting videos. And till then, thank you so much, and I'll see you soon in the next video. Thank you.